Good evening, everyone. Thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at helping you use multiple representations with the TI-84 Plus family. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough to teach, tough to learn concepts accessible to all my students. And with us tonight, we have Dawn Meitler and Deb Nutt. Dawn is a K-12 instructional coach in Freeland, Michigan, specializing in math and technology. She has previously taught middle and high school math and STEM for 24 years. So Dawn, it's great to have you with us.
Thank you. It's good to be here.
And Deb was in education for over 30 years, teaching all levels of algebra at Salina High School in Salina, Ohio. She became interested in graphic technology to help her students better understand math concepts and became a T-Cubed regional instructor in 2007, allowing her to keep up with the newest technology and pedagogy. Now retired from the classroom, she still enjoys working with teachers and the T-Cube family by presenting at local, state, and regional conferences, as well as workshops, webinars, and T-Cubed events. So Deb, it's great to have you with us as well.
It's great to be here, and I hope we have a good evening and learn lots of things.
All right, Deb, keep that flow rolling. Can you discuss our agenda for tonight?
Our agenda tonight, we're going to look at welcomes and introductions, which we've sort of done. Then we're going to talk and start using some middle school concepts and talk about patterns with fractions, proportional reasonings, linear fit with the manual fit line, looking at systems of equations, and hopefully having time for piecewise. And then at the end, there is a webinar drawing. I'm going to try to see how technology can be used to look at these things, as well as concepts that can be applied at the middle grades and lower high school levels.
Deb, thanks so much. And Dawn, will you talk through our expected outcomes, please?
Yes, our expected outcomes tonight at the end, we want to hopefully see that you can use multiple tools and features with the TI-84 Plus to teach middle grade concepts. And we can use technology to extend the concepts for deeper understanding and connections for all learners. Technology allows very complex mathematics to be reachable for all.
Thanks so much. I'm really excited that so many people are already using that chat window to let us know where you're joining from. That's one of my favorite things to see every week is just how far and wide these webinars tend to reach. So thanks everyone for joining us and for using that chat window to let us know where you're joining us from. If you have any questions for Dawn or Deb, use that Q&A window on the right side of your screen. And as a reminder, tonight's webinar is recorded and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. All right, Deb, it is all yours.
All right, get my screen up here. And can you see it, Mike?
Not yet. It's coming.
Okay. Oh.
There we go.
Okay. All right. Say good thing I didn't start. All right. I want to start by talking a little bit about patterns with fractions and how we can maybe get rid of some of the fear that our students have with fractions. I know my students always came to me and they hated fractions. I had one tell me one time, well, that problem had a fraction in it, so I just skipped it. And I think if we look at some of the patterns that happen, we can get our students starting to talk about it, maybe overcome some of their fear with fractions. And I always try to say fractions are fun in my classrooms and that kind of thing. This is an activity. I don't have a specific thing written up for it. I'm going to do it sort of as a teacher-led activity. It can be done fairly quickly. Wonderful first day of the year to start getting students to talk mathematically and look at things, maybe after a test or something like that, where you've got some time. I know in our school system, we have school delays all the time. We had a 2-hour delay today for fog in the area. So when our school did that, we had like 20-minute classes. And what can you get done in 20 minutes? So filling in some teacher-led activity like this, still doing some real math work, but yet the kids don't realize necessarily that they're doing math work and what's expected. So what I want to start looking at is just these 3 addition problems. And you can start using your chat window if you want, and Dawn will let me know what's being said there. But if you look at just these 3 problems, notice I don't have any answers right now. I'm not concerned with the answers, but just what are some similarities that you see with these three problems, so that we can start looking at how are the problems similar to help us then see what happens with the answers eventually. So if you can start using the chat, and Dawn letting me know what's in the chat, since I can't see the chat with my screen right now. What are some similarities that we are seeing?
Okay, seeing all numerators are 1.
Okay. That's real obvious, and the kids always seem to come up with that one.
Denominators are sequential, I'm seeing.
Okay.
Somebody put it's 1 over n plus 1 over n plus 1.
Okay, we're going to get into talking about the algebra that we can do with these eventually as far as that goes. So those are the common things, and hopefully we can get our students to talk about 3 or 4 different things with it. I like that people are using the vocabulary of numerator and denominator. Again, I know a lot of students come into my room and they talk about the tops and bottoms of fractions. And I'm going, oh, when they start talking about a top of a fraction, I'm going, oh, are you talking about your pajamas? Because yes, your pajamas have tops and bottoms, but fractions, they've really got numerators and denominators. So trying to get the correct vocabulary involved as well when you're doing some type of activity like this, to get them to think about that, so that when they're having to write in those open-ended questions on testing, they're using the good vocabulary at that point as well. So once we've talked about the problems themselves, then we're going to want to go and look at our answers that come up with these. So I'm going to go ahead and get to the Smart View and look at the 84 calculator and how we can do these problems with our technology for a quick way. And one of the great things about the 84 calculator is that we can get the fraction to look like a fraction. Okay? And now the easiest way to do that and to come up with our fraction template is to use the alpha key and then the X key. And again, so many times with the calculator, there's more than one way to get to something. So I'm simply going to type in my first problem that I had, which was the fraction of 1/2 added to the fraction. And again, to get the fraction 1 or alpha x, and then I have my 1 over 3 get outside of my fraction. Okay, and I'm just going to hit enter, and I find that I have a sum of 5/6. Okay, simple enough. Okay, I'm going to type in the next one. And Dawn, if people have comments or anything at any time, let me know. 1/3 added, whoops, I hit the 3 instead of the plus sign with my fat fingers. The fraction of 1/4 now. Hit enter, get 7/12. Might start to see some similarities. Now, another way I can get this, notice if I up arrow on my calculator, I can highlight my answer, I can highlight a problem. And once something is highlighted, and it's light green, so sometimes that's a little hard to see, if I hit the enter, it cuts and pastes it. So rather than retyping everything, I can cut and paste and then just type over my numbers. So I'm going to have my next problem, which is 1/4 added to 1/5. Get outside of it, hit enter, have a sum of 9/12. So now I have those 3 problems. We've come up with the answers to those problems. Now we have to shift a little bit in what we want to look at. I want to be able to compare my answers with my problems. And can I come up with some conclusions or a pattern that can be done so that I can easily come up with my sum from just looking at a problem? In other words, what can mathematically be done to come up with the 5/6 for my 1/2 plus 1/3? And again, using the chat to sort of get some responses in. And what can be done with our problem so that we come up with our 7/12 for our second problem?
Yep, so I'm seeing the numerator is the sum of the denominators, and the denominator is the product.
Okay, numerator is our sum and our denominator is the product of our denominators. And so again, we know mathematically why that's happening, knowing how fractions work, and we have to get our common denominator and then we make our equivalent fractions. Okay, and so the next logical thing to say is, okay, does it only work for these 3 problems? Or can we go on and have more problems? You know, if I try to continue the pattern, you know, my next fraction or my next problem would have to be that 1/5 added to the 1/4 or 1/6. And if we look at that problem, and if our pattern continues, if I take the sum of my denominators, which was given, would be 11, and the product of my denominators, you could ask your students, what do you expect it to be before you ever hit the enter key? And do we get that 11/30ths? And yes, it does. Okay. Does it continue? And you can have some more. But then another logical question is, do they have to be consecutive? Do they have to be, two fractions that are right next to each other? Or does my next one have to be 1/6 added to 1/7? Can we skip a few? Have your students come up with a problem. Maybe a student suggests to do something like 1/20th added to, and of course the next one should be consecutive with the pattern, but we've not necessarily done the next consecutive number. Okay? And would I expect to get my sum for my numerator, which would be 41, and my product of 20 times 21 or 2 times 21, and then add the 0 of 420. And it continues to work. Okay? Does it always work? And if I go back to my examples here, I did that problem of the next one, what's the next one? Does it work? Yes, it did. Does it continue? We can try some more of them, ask students to give suggestions to see what happens. And so I had some problems, right? But then, of course, another logical question is, does the pattern work if they aren't consecutive? What if I take a 1/2 with a 1/5? Or I take a 1/2 with a 1/7? Does the pattern still work as far as what my sum is going to be? So if I have that 1/2 added to the fraction of, I think I said it was 1/5, would I get my 7/10? And yes, it works. So they weren't consecutive. Now, yes, every time I've had 1 in my denominator, or excuse me, in my numerator, does that have to be a place? We could try that. Of course, another thing would be to try, what if I take something like my 1/2, and I'm going to go up and cut and paste this one, and instead of saying 1/5, what happens if I use a 1/8? Okay. And what happens then? I would expect that to be 10/16 if my pattern continues. If I sum my denominators and I product my denominators, oh, wait a minute, I didn't get 10/16. Okay, well, what happened there? And some of the students might say, oh, well, maybe it was a reduced fraction. Are they the same? Well, here's another thing that we can do with the technology is we can check equivalency. Is my 5/8 the same as my expected answer? So I'm going to cut and paste that 5/8 that my calculator gave me, and I'm going to test and see if what I thought it should be is the same. So if I'm going to do a test, I'm going to do on the calculator a second test key, and we get these inequality symbols and things, but number 1 is an equal sign. So when I hit enter, I cut and paste that equal sign. And what we wanted to thought would be our answer was going to be the 10/16. And if I now hit enter, it's going to tell me whether this is true or not. It doesn't give me the word true, but it does that Boolean testing idea where 1 is a true answer and 0 is a wrong answer. So we know that now 5/8 is equivalent to 10/16. And then we can maybe get into why are they equivalent? What happened to that expected answer of 10/16 to give us the answer of 5/8? And hopefully our students would start to recognize that, oh, they were each divided by 2. Okay? Now, again, talking about that testing, if I cut and paste, again, I'm going to go down and I'm going to change this to 10/15 just to show you what happens when something is not equivalent. Get a false answer and it shows us that it's a false answer because of 0. So again, if you want to test things and see if something is true or false, if things are equivalent or not, you can use that testing feature. And again, to get to that equal sign, it was second test. And then we could do equal sign. You could do inequalities as well. Is one fraction larger than the other one? And, it will give you that answer. And so if I do that, it pastes that equal sign in there. Okay. So again, this is just sort of a little activity that can be done fairly quickly. You could write up a worksheet if you wanted to with the problems and have the students test them and write their answers, or I should say use the calculator to come up with the answers and fill it out. but sometimes it's just sort of fun to have a teacher-led activity and get the students involved by answering questions and things like that. So I just thought this was a little activity, get to work with some fractions, maybe overcome the fear. Hey, sometime when they want to do something quick, hey, remember that trick that, as long as our numerators were 1, we could multiply our denominators. For our new denominator, we could add them. We might have to do some reducing at that point, but we can at least, not, get over the fear of, oh, we have to make those equivalents and so much work and things like that. And again, I think we could also use this with testing. Algebraically, we could prove it. Once we've talked about it, we could take the idea, and someone earlier in the chat had said that we could say that it's 1 over a added to 1 over a plus 1 and come up with our common denominator of a times a plus 1 and numerator of a plus 1 added to the a. And, algebraically show why this works, that it is that first number that we multiply by 2 and add 1 and things like that with it. So any questions or comments just coming in general about the activity and what's being done here as a way of looking at fractions and things at the same time? Yes, you will be getting a copy of the PowerPoint. It'll take a couple of days as far as that goes, but you will get a copy of the PowerPoint and the presentation. So you could have those as far as remembering what they were and things like that. Yes. So I think with that in mind, Dawn, it's time for you to take over and talk about proportions.
Okay. I do want to say that I am sending emulator states in the chat or with the documents. So if you don't want to follow along on your computer, some of the data that I'll be working with, you'll be able to recover the emulator state. So I pulled an 8th grade math problem from illustrative math to kind of dive into proportional reasoning. And proportional reasoning is a hot topic for 7th and 8th grade. So I'm going to look at this problem to start. Jada and Noah counted the number of steps they took to walk a set distance. To walk the same distance, Jada took 8 steps while Noah took 10. Then they found that when Noah took 15 steps, Jada took 12 steps. So as you can see, these 4 questions are very typical things that we would be asked. Create a table of values, graph the relationship, how can you see or calculate the constant of proportionality, and then explain how you can tell that the equation, the description, the graph, and the table all represent the same situation. So when we talk to students about proportionality, I think it's really important for them to kind of realize or make some connection about what it's standing for. So we're going to jump to our Smart View. And the way we're going to approach this is by putting our data in. So I went to the Stat menu to edit and put in the Jada into L1, Noah into L2. And at this point, you would begin to ask your students, okay, we need 3 points for our table. So what patterns do you see? So Deb, I'll let you man the chat, but just go ahead and put in there what patterns do you see in how Jada is walking versus how Noah's walking, and what should be some next values here.
I say adding 4.
Good.
4 and then a 5 for the Y. Put a 4 in the Y.
Okay, so
I have a feeling there should be an X in there. It may have gotten left out on that comment.
Yeah.
Say another idea of using 4 and 5 for things.
Yep. So students begin to see this pattern. And at this point, you could ask, what does this mean about the way they're walking? When I modeled this with my classes, I said, I had some people get up and try to map it out. And they talked about who's walking not faster, but whose stride length is longer because it's a set distance. So we get this typical data here. So then we're going to teach students that we press second Y equals to turn our stat plot on. And we do that by toggling the on and off button. We want it to be a scatter plot. We want our X values to be Jada and our Y values to be Noah. And that's just a matter of preference. It doesn't really matter. So I talked to students about how you can see plot number 1 is on because it's dark, and you want to make sure these other plots are not on at the moment, or it's just going to interrupt what we're doing. So if they were on, you would just hover over them and toggle them off or on. So at this point, we want to graph this. So when students hit graph, we say, uh-oh, something's broken. So it's a great teachable moment. Why can't we see the data? And I purposely like to have students struggle with this so that they can realize, and it really ties to them, the idea of setting your window and understanding the data. So we have a good discussion here. And although there's a quicker way to set the window, I think it's important to start out with a discussion of pressing the window button, because you have some rich discussion here on domain and range. And so I review that X stands for JADA steps. So what's the smallest amount of steps that JADA could take? Well, 0. And then our data, we went up to about 28. So I'm going to go 30. And the tick marks, I usually go by 2s. The Y values, we're reinforcing that that stands for Noah's steps. The least amount of steps he could take is 0. And I think his went up to about 40. And I think it's really important. Earlier in my career, I really skipped this step too often because I was in a hurry and I would use a lot of the Zoom stat or the Zoom standard. But as I've taken more time to have students really struggle with this window and realize that they were in control of it, I noticed a much better understanding of domain and range. So then we go back to graph, and sure enough, we can see this data coming in here. And students at this point are starting to see that it looks linear, but we're still not necessarily sure what kind of pattern is going on here. One thing that I talked to students about when I did this is I said, we're trying to decide if there's a relationship between them, and does that mean that the distance between the two people is going to be constant? So I'll give you a minute. If we think about at any point how well, I guess that wouldn't be the case because it's a set distance, but you can see that there's a difference of 2 steps in the shorter distance. Then it takes a difference of 3 steps and 4 steps. So we see this kind of growing distance here. But when we get to this graph, we're still not really sure what this is representing. Okay. So one of the things I love about lists is if we go back to the list feature, we want to go over to L3, and we want L3 to actually calculate much like an Excel spreadsheet. Okay, so I'm going to move my up arrow till I'm on L3, and we really want to think about what is the multiplying factor? How many times bigger, how many more steps does Noah have to take, or how many times bigger is Jada's step size than Noah's step size? If it takes her 8 steps to walk to the wall, takes Noah's 10 steps to walk to the wall, we know that Jada has a longer stride, but we want to figure out what that relationship is. Okay. And I got ahead of myself before we get to that. When I get here, we stopped and we talked to the students, and I said, okay, let's go to Y equals. What if we typed in Y equals X? And I got them to realize that in that context, that means Jada and Noah's step stride length is the same. And then we graphed it. Then we changed it up. We said, that didn't work. Let's make another guess. So somebody said, well, maybe Jada's stride length is 2 times Noah's. And we saw that that was a bit high. So a lot of my students guessed 1.5x, and we kept kind of played with that a little bit. But for the sake of time, I want to go back here, and now we want to actually calculate what that multiplier is. So when you are in L3, we can actually calculate Y divided by X. So to do that, we are going to press second and the number 2 button, because we want to do L2 divided by L1. And just like Excel, it will, once you do that formula, it will calculate that and put it in all the way down here. So then I had a discussion with my students. What does this mean? We've got this 1.25 here. So we tried it. And you can either type in 1.25x, or you could say we want to take what L3 as our multiplier. Okay, and I did it both ways just because I didn't want to confuse the students. But when we hit graph here, we now see that it's a perfect fit, and we begin to talk about that. So Jada's steps are about 1 1/4 times longer than Noah's steps. Okay. Then we can use this data to start to extrapolate. So I'm going to go back to my screen here. So I've got all of this that you'll get screenshots of everything. But then we want to say, how many steps would Noah take if Jada took 50 or 200 or 400? So because our data is all set to go, we can go back to the stat menu. And what I like about this, we're going to go back into Jada's and we're going to put in 50, 200, and 400. So that's how we want to, those are the input values that we want to calculate now. And I'm going to pause for a minute and let you guys give some ideas. How do you think you would go about getting students to predict this L2 value? When L1 is 50, how would you get them to think about it? Or what might you ask next? So I'll wait just a moment.
See, they did like that the line that you came up with was the perfect fit. Somebody's saying to multiply by L3.
Okay, very good. So that's exactly what we're going to do. So if you can see that right here, we're in this position, we are going to tell it to take 50 times whatever's in L3. Ooh, that worked before. What did I do? Maybe you just do 50 times 1.25. There we go. Okay, so we can very easily begin to calculate within the table, which is a nice feature, and we can extrapolate that. Now, students might say, wait a minute, are we sure that these are proportional? So we can go back over here to L3, and we can tell it to do that calculation again. We can say take L2 divided by L1, and it should fill everything down, and we can see that those are still in that proportional state. Okay, now again, you graph, and you're not going to see those new values, so you can have another great discussion here about setting the window, or like I saw many people in the chat said, you can do zoom stat, and it will automatically fit that. You can hit the trace button here, and you can see that we are plotting along all these little points, and then there's our extended points there. Comes out to be a perfect fit. Now, in the slide presentation, I do talk about how you can use what Deb was saying earlier to check these proportional relationships. And since she already introduced that, we don't have to go over it again, but we can continue to talk about that. But we come back to this leading question of what does this 1.25 mean? And so one of the nice things about the calculators is that using what Deb began with the fraction model, we can take this y divided by x and it can simplify as 5/4. So a lot of students said every time it took Noah 5 steps, Jada could do the same thing in 4 steps, that 5 strides of Noah's would match 4 strides of Jada's. But then that's not what we are seeing in our equation. So if you don't use that fraction template, if you just do 5 divided by 4, that's how you can then get the decimal representation. And then you can see I really like that fraction model of how it represents as you work into the next steps of being rate of change or slope. That model that Deb was showing fits really nicely for that. So before we move on, are there any questions?
I say nothing question-wise has come up, but we've had a comment that using the lists is handy to do some of the calculations by going up to the top like that.
And I saw
that 1.25 is a constant rate of change, making sure that we point that out to the students and stuff.
Yep. Okay, Deb, I think it's your turn.
Okay, so I will go back here. And a lot of what Dawn just talked about, I'm going to be touching on again as well, because I'm going to talk about linear functions and look at an activity that is called You Are What You Eat. It is not something that I created. I have used it in the classroom. It is actually an activity and a lesson that is found on the TI website. And as most students are interested in anything that involves food, this is an activity that gets their attention. I like this activity for several different reasons. The basic concept of this is that it compares the amount of fat in some hamburger from the local restaurants and the common places compared to the calories that are there. And when we talk about multiple representation, one of the things that I was very weak at for a long time is I would get a set of data, whether I got it from a pre-made activity like this, or we did some data collection in the classroom itself, and we'd get the data and we would go straight into the graphing and straight into the analyzing of the data. But we never really, and I didn't stress looking at the table itself. This data collected, can we come up with some things about the data itself? And so this first question here does that, and that's why I really like this activity a lot, is to look at the data, look at this table that you were given, and what do you think is the relationship between the fat and the calories? Is it positive? Is it negative? Is it constant? Do we think it's going to look like if we have it? Is it, growing at the same exact rate? And we had a perfect fit with Dawn's lesson there on the proportions, where we had a 1.25 change as far as that goes. Is that going to be the same here? So again, I don't know if anybody's answering that in the chat or anything or looking at it, but I think you look at that. And then even the next questions, and again, this is wonderful, is what's the independent variable? What's the dependent variable? What's the domain and the range? So it gets the students to start looking at the data itself, the numbers that are given in a chart or the numbers that are collected about something, and just looking at those. And this idea of talking about the domain and the range, as Dawn said, is wonderful for helping to set up your window and things like that with the calculator. So once we have this, what we're going to do, as usual, with the calculator and the handheld is come up with another representation for it, and that is to come up with a graph and eventually come up with a line of fit. So what I have done, again, to save a little bit of time, is I've sort of set up things. I always told my students, as Dawn mentioned, that there's always 3 things you have to do on your calculator before you're allowed to hit the graph key. And one is to enter your data. And as Dawn said, you enter your data by using the stat key and then editing. And again, you see that I sort of, to save time tonight, put in that list of the fat grams in L1 and my calories in L2. So I just copied those things. I typed in my 9 and 19 and 24, went over to L2, my 270, 270, 360. So again, it's that same set of data. I've just put it in L1 and L2. The second thing that we always have to do before we can hit the graph key is to decide what kind of graph we're going to make. And so that again is through the second stat plot. I'm going to turn on my first plot. I can have a scatter plot, which is my first one, or a connected plot. So that's already set up. I have my information in list 1 for my independent. List 2 is my dependent. I don't have that many pieces of data, so using the square or the plus. I remember somebody at one point in time said, like, if you had less than 10 to 15 pieces of data, using the square or the plus is good. But if you start to have more than 15, and heaven forbid you have something like 40, 50 pieces of data, using the smaller symbols is better because they don't overlap each other and stuff like that as much. So I've turned on my plot, and then very much like Dawn said, especially with the lower grades and with Algebra 1, I want the students to think about the data. We're trying to make these connections with the multiple representation. So rather than using a Zoom stat or a Zoom fit, I always go to the window and have my students to decide. Because so many times if you do a Zoom fit, you're out there in quadrant 1, axes are not showing up, and you really have absolutely no idea where you are in the middle of quadrant 1. So you come up with this line, and then you don't know where that line is crossing an axis. Does it even cross an axis? Is it positive, negative? So I always had my students use their window. It makes them go back and look at their data. as far as things are concerned. So they have to think about what their minimum and their maximum is going to be. Again, that goes into what was the domain. And one of the rules in my classroom so that the axes would show up is I always, and I started this when we had the what's the gray screen, the old 83s and just the non-colored 84s, is the axes wouldn't show up even if you put the 0 in because there wasn't the border around it. So my rule was you always had to have a negative minimum number that guaranteed that my axes would show up. So I set my X minimum as -2 to 1 and my maximum to a 100. Wasn't that much, so the tick marks at every 10. My Y minimum, -10. My largest value was 1060. So always go a little bit more. So I went to 1200. Again, that was a bigger range of numbers. So I made my scale at 100. And again, I'm going to send, just as Dawn said, the emulator state's going to be given to you. So you'll have this window that you can look at and things like that. But again, the good discussion of what is that domain in the range. So they have to think about what their maximum and minimum needs to be. So again, 3 things to do before you're allowed to hit the graph key. One is to enter the data through the stat and edit. A second thing is to turn on the graph by using the stat plot, second stat plot, make sure that it's on, because so many times they think they've turned it on, but it's not. Okay? And then to set up the size of the graph by using the window screen. Oops, using the window screen, not the second window. Okay? And knowing what's there. And then you're allowed to hit the graph button and hopefully you get a good scatter plot. And I know in my classroom, I think maybe 3 or 4 times when I was doing a group activity where I got the whole class to come up with a graph the very first time. It's like, my calculator broke. I didn't get a graph. I only got 3 points showing. I got an error message. And, so then you have to go run around and, figure out what happened with the students. And I think 3 or 4 times over the years that I actually had every student in the classroom come up with a graph the first time that they hit it. And that was like, oh my gosh, what a good day that was when you didn't have to go around and try to figure out what happened. So then we can go back and ask the question with this. We looked at the table and we said that the table basically was a positive relationship. It looked like it, hopefully if we graph it, it'd be going up to the right, and it worked. Dawn's data, again, wasn't an exact proportion that I could come up with that rate of change that was constant. And I could do that in my L3, as I could take L2 and divide by L3. Would I get a proportion that every difference was the difference was the same? And it wouldn't. I think looking at the graph, you see that as well. But we'd come up with our line of fit. Now, what Dawn did with her students, and I like that idea, was to go to the y equals and sort of, what I sort of called was guess and check. Put in the basic linear equation of y equaling x and did it fit? Well, it wasn't enough. So, if what happens if we did 2x? And we could do that with guess and check in the y. But something that a lot of people aren't familiar with, which I think is a wonderful idea when working with data, is to use a feature called the manual fit on the technology. Okay? And so to find manual fit, I'm going to go to the stat key and I'm going to go to the right, which is calculate. And this is where you can do all of your regressions. And yes, we could do a regression with this and come up with a good line of fit. But if I up arrow and I go to letter D under the calculate, or I could down arrow a bunch of times until I get to the letter D, you see there is manual fit for y equals mx plus b. And manual fit is a wonderful idea if you have something that looks like it is linear data. This can only be used if it was linear. If you were looking at a parabola shape or an exponential shape, you would not be able to use manual fit. It can only be done if it looks like you have a linear relationship. So I'm going to hit enter to turn on my manual fit. I want to store my equation once we calculate and come up with it. So I'm going to use the alpha trace key because that is the shortcut now to get to all of my equations. I'm going to simply store it in Y1. The other way that you can get to it, the Y1, is to go to vars and then over to Y bars and things like that. Okay? But again, there's multiple ways to get to everything. I'm going to go down to calculate. I hit enter on calculate and it takes me back to my graph. And you'll see some changes in the graph now and some things have been added with it. One, it says in the bottom left that I'm going to drop points And I have this big black cursor sort of in the middle of my screen. It says X is 49, Y is 595, and that's that actual point. And if I use the arrows, excuse me, on the calculator, I can move that black cursor and my point values change. Now, I also notice those point values are in blue. So there's this pop-up of style right above the graph key. So I'm going to hit my graph key and I'm going to change the color so that it's red. And I'm going to change to a little thinner line just so I'll be able to see my points at the same time I am seeing my line. And again, that was just by using the graph key, which is right below that little pop-up of style. And now when I go back, you see that my drop points and where I'm at is listed in red. And that's just for clarity. And that's one of the advantages of having the color. Now, you could do this with the regular 84 that is not in color, and it works. The manual fit is a part of it. It's just that you don't have the advantage of seeing your scatter plot in blue and your line of fit in red. So I just move my little cursor guy, my little flashing light or whatever, to what looks like might be a good beginning point for a line, and I hit enter. It doesn't look like anything's changed or is different till I start to move away. And you see that I have this line forming, and I can go up and down. And I'm going to try to do what so many of my students do when we're starting this, is if we're doing line of fit, they say, well, my line of fit has to go through my first point and my last point. And if I can get my line, oops, I went back to, now I might have to start over with my, no. If I go through my first point and last point, then I'm going to have a good line of fit. So, okay. And they may think that, and that's fine. And, you know, and in fact, I'm going to do this to show some things with this manual fit. So if I'm okay with that, and I think that looks like it's a line of fit, I'm not sure what I've done here as far as, okay, I've dropped my point. I hit my second point. If I think that is a line of fit, I guess I forgot to hit my second point and enter it, and that's why it didn't happen. Notice my style has now changed to a pop-up of done, but in the upper left, I now have an equation written in there. I have an equation of y equaling 11.197x added to 1.79. And basically, that was when I tried to get my line to go through my first and last point. If I use my right and left arrow, I must have hit graph or done or something. Okay. Yeah, it did. I'm going to go back. I'm going to clear this out. I'm sorry. I want to clear that out. I'm going to do my stat manual fit again because I want to show what can happen as I'm fitting this line, that when that shows up there, I can, you know, make some changes with my line. So again, I'm just going to pick a point, and I'm going to do this quickly just to get it done so that we have time to get to other things as well. But if I put this in and I say, oh, that's a good line of fit because I've got some above and some below, okay, it shows me this equation. If I use my right and left arrow on that equation that I now have up there, notice that I can then change those. You know, is this a good line of fit? Well, yes, I have some above and some below, but is it really close to them? And I think we were closer when my slope was 11 something. So I can type in when the box is around the number, I can type in a value. So I can type in something like 11 and hit enter, and it will change my line for me. Well, that makes it look a little better, but my slope seems, you know, my y-intercept looks pretty high. What if I change my y-intercept to something like 150? Because remember, we had a pretty big y scale on our range there. We were up to 1200. Okay? I'm getting a little closer. And my slope needs to be increased, maybe a little more. So what happens if I put in something like 11 and a half? I am having a problem. Oh, I hit the comma instead of the death period. 11 and a half. And there's an advantage, teachable moment. I had a mistake. I had the option of either quitting or go to. And my students, it's never okay to quit. And I don't know what I've just done there. Sorry. You know, so we're getting close. When I am done, then I hit that graph key and it redraws the line. And then when I go to my y equals, I have that equation. So using manual fit is sort of what I used to do with paper and pencil long before I had the technology, where we would plot points on a piece of graph paper. You still had to set up the size of your graph, figure out what your scale was going to be, what each line was going to represent. And then we drew in a line of fit and traced it and calculated points and, got something that was a line of fit as far as looking at things. If I go back to the activity itself, one of the things that's nice about the activity is this particular activity goes through and talks about how to turn on your scatter plot. So it can almost be something that you could use in class and not have to teach the whole process, because it's in the activity, how to do the manual fit by storing the equation and things. It also talks about a regression if you wanted to do that. But I like the questions at the end as well. What does the y-intercept mean in terms of the number of hamburgers? And if you think about that, you could write something in the chat, or how many calories are in a hamburger if we have 22. And there's multiple ways of doing that. We could use the equation on the home screen and calculate it. You could trace until you came up with 22 grams of fat on the line and see what the calories were and things like that. So there's these good extension questions with the activity. And then even some extensions and other things that you can do. If you wanted your students to actually collect data, have them look up the grams of fat and calories for hamburgers. Get some of the local restaurants in town, besides the McDonald's and the Wendy's, that have hamburgers, and have them call or look on their websites. Using chips or candy or something else. I thought it would be neat to have each of your students bring in a little bag of their favorite chips, and maybe split the room in half, and half of the students record for their chips and the other half of the room record for their chip bag while they're doing their activity. Then they get to eat their chips. Of course, if they get to eat in class, that's always a good day for them, but yet they're doing math at the same time and things like that with it. And again, anytime the kids can eat in class, I think that's a good thing, especially with middle grades and stuff like that. So have any questions or anything been coming in, Dawn, to try to go through or
No, just
discuss with
reinforcing.
the activity?
Yep, just reinforcing how important it is to teach them to edit their window settings, and just that this is really rich learning in 7th and 8th grade.
Yeah, and I think the idea of trying to tie in the multiple representations again, that we had the table, that we had a scatter plot, that we put in a line, we looked at the equation, we used that equation, a way of finding that equation and stuff like that. For the multiple representations and tying it all together. It's not just something arbitrarily, some graph looked at in a book. Okay, what's the equation of the line of this graph and stuff?
Right.
So I think with that, Dawn, it's back to you
Okay.
to talk about systems.
Yes. So I pulled up another problem that is a very typical 8th grade system problem. So Diego and Lynn are drinking milkshakes. Lynn starts with 12 ounces and drinks 1/4 ounce per second. Diego starts with 20 ounces and drinks 2/3 ounce per second. So because of time, I already have a screenshot here of how you could enter this manually for Lynn. So notice that L1 here is just going to be the seconds that we've drank. L2 will be Lynn. And this is not a hard one for students to, enter, because it's 1/4. So I did that automatically. Whoops. But then when we get to an easier way to do that is, like I said before, we can instead generate Lynn's output by putting in a formula. So I go up to L2 again, and we are going to start to develop this function rule. So she starts with 12 ounces, and she is drinking 1/2 ounce per second. Oops, sorry. And our output, our seconds, is in L1. So we enter that, and it pops our data in. So that's a really nice way to approach that with students. And then we want to, at the same time, look at Diego's data, and we're going to put that in by, again, being in L3. And he starts with 20 ounces, but this time we're going to subtract, and we're going to go back to what Deb shared with that function or fraction template. We're going to press second and the variable key, because we are going to subtract 2/3, and we don't want to do a decimal approximation. We want to actually show that he he's going down by 2/3 of an ounce per second. So if you notice that when you do it like that, by using that fraction template, your data comes out really nice in these fraction bars. And so you can scroll down and we can see that. Okay, so just another good representation. Then, of course, we want to graph this and we want to figure out when are they going to have the same amount of milkshake left. So when you go to your window, because of time, again, we could have that discussion, but I'm just going to go to Zoom Stat. And Zoom Stat is just an easy way. It's going to automatically set your window based on the data you have. And good teachable moment. What did I forget to do? Anybody see? I forgot to clear my list previously. Now, one thing that I skipped over because of time is I already have 2 plots set up. So I have the data for Lynn into L2. So I turn plot number 1. That's going to put the X value is the seconds. The Y value is going to be Lynn's drinking pattern. In plot 2, I set that to have an X value of the seconds, which is L1, but Diego's is L3. Okay, so when we see a graph here, we get this picture. And again, that does not look right. Did I do something wrong? No, I don't think so. So the next thing we can do is we want to see where these intersect. Now I just want to double check to see, did I do that right? I did that right. Okay. So we want to expand out this window because they did not match. They did not intersect at 9 seconds. So I'm going to put that out to 20 seconds. And let's see if we can start to see that. So we can kind of see they're going down, but still not great. So instead, we're going to go to y equals, and we're going to put into y equals. Somebody said, turn off my other lists. I think they're all
That
off.
was an answer to the question when you had your lines there.
Oh, okay. So
Yeah,
we're
so
gonna,
you're okay with that? No.
instead, we're
you'd
going to
already-
go back
yeah.
to y equals, and I'm going to put in that same rule. So we've got Lynn starts with 12 ounces, and we're going to generate our function rule and see if this fits our data. And this is really typical for 8th graders. They should be able to get to this step, and you wouldn't need to do that scatter plot. In fact, I wouldn't very long in my work with systems. I would go right to this function rule. But just to verify, we're going to see that they're fitting here. Okay, now I need to fix my window. So let's see, what do I need to fix here?
So try to get some kind of a negative Y minimum so you can see the axes.
Yeah, and then I think this is going to go out farther.
I think it might show up because
There we
surely
go. Oh, went a lot farther than I thought. So we kind of do this playing back and forth. I think I typed something in wrong because it should, the x-intercept should have appeared. Okay, so big prize for who can tell me. Oh, 1/4 of an ounce. Thank you, Daniel. I read it wrong. Yes, it's 1/4 of an ounce, not 1/2 an ounce. That was my problem. There we go. Okay, so I'm going to just turn these plots off since I entered that wrong. Oops, it's going to turn this off. Turn this one off. And so we get to this nice scatter plot. Sorry about that. So we get to this very typical problem. 8th graders don't have a problem with this, but we want to really focus on this point of intersection. So we all know you press second trace to get to the calculate, and this is where you can really see some magic happening. So to find the intersection, you just move close to the points on the first curve, hit enter, enter, enter. And we can see that after about 19 seconds of drinking, they both have about 7.2 ounces left. Okay. So that's just another way to kind of start looking at systems. I think with the list menu, if I would have typed it in correctly, you could have seen a nice picture and it becomes a good progression. I probably won't have a ton of time to talk through this next part, so I will just show you the presentation and you will get a copy of it. But the next step that I often do with my students is we play around with this idea of piecewise functions. Now, piecewise functions would definitely be an extension for traditional 8th grade coursework, but I teach 8th grade or Algebra 1 in 8th grade. And so I have found the students really have a lot of success with this. So I'm not sure if you're aware, but if you go into the Y equals menu on a brand new screen, and if you press the math button, let me go to that. So I'm going to clear these off. You have to be sitting in the Y equals first. Then if you press math, and if you do the up arrow, you're going to jump all the way to the bottom of this menu because we're going to select piecewise. And you can get up to 3 functions. So I'm just going to go 2 for now. And this really generates some cool functions. So you can put in any rule you want, x plus 2, but then we want to limit the domain. So this is some really great discussion. So you would do it just like Deb said earlier. We want to limit the domain for x. Then we would go to this test feature, second math, and that's where we get our inequalities. Okay, so you can do some things like that, have students start playing with piecewise functions. But just in closing, I want to show you what my students came up with. So we started doing this, got the logic conditions, and you'll get a copy for all of this. But then we started predicting what was happening with these points of discontinuity. So one of the things I love the most about technology is I feel like it takes these really big mathematical concepts. I mean, these are pre-calc and calculus concepts, but we were able to dissect them and really explore them in 8th grade by talking about these breaks in the graph. So it really led to some great discussions. You can see what discontinuity looks like in a table. We started talking about that. And then last year, at the end of piecewise functions, it was right about Valentine's Day. I challenged them to make some piecewise functions to come up with some kind of a Valentine's activity or a Valentine's diagram. So this is what some of my Algebra 1 8th grade students were able to accomplish. So we had already discussed absolute value functions, different function families, and I was just really impressed with the amount of knowledge that they were able to replicate by just using that piecewise feature. Are there any last minute questions? It looks like we are really close, but you will get a copy of all of this, and I hope that you learned something tonight.
See, one thing I just want to make a quick comment on. Somebody in the comments had talked about being rich activities and if all the students would have access to the technology. Even if you don't have a classroom set of handhelds that can be done, doing teacher-led activities with just the Smart View still gets the idea across, just like we've done tonight. We've showed you the things. We didn't have you each using a calculator in their own hand. And that's how I truly started at my classroom, is I would just demonstrate with my computer on the screen and showing it, and it tied it in. And eventually we were able to get class sets and require our students to have it. So you can start small with just one and showing it as we did tonight to make those connections so that they see it later on and things like that too, if you don't happen to have a class set. So Mike?
Thanks so much, Deb and Dawn. As we wrap things up tonight, we are promising that one lucky winner was going to win a TI graphing calculator of their choice. And tonight's lucky winner is Dr. Vanessa Sims. So Dr. Vanessa Sims, congratulations. We'll be in touch over email very soon to get some information from you, but congrats on winning our webinar prize. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed as a link for the documents that were used tonight as promised. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. When you leave the webinar tonight, a brief survey automatically appears in your browser. Your feedback guides us as we plan future online events. It really does help. I hope that we had a really great crowd on tonight that was excited about some of the stuff that Dawn and Deb shared. And if there's other things that you'd like to see, we'd love to hear that too. So again, please share your thoughts in that post-webinar survey. Huge thanks to Dawn and Deb for putting everything together tonight. I know they worked really hard. The documents that they are giving to you right now are really rich. So make sure you take a look through those as well. They're really nice and complete. And so just a huge thanks to them for everything they did tonight. And thanks to everyone else for joining us. We hope to see you back online next week. Have a great night.
Night.
All right.